Hi, welcome again. This is the sixth video of our course Numerical Analysis for Computer Engineers, and today our subject is solving systems of linear equations. Our subject is solving systems of linear equations. So, what do I mean with the system of linear equations? What do I mean? System of linear equations. Let me give you an example. For example, let's say that we have two different unknowns. We have two different variables, for example, x and y. And we just have two different equations. And they are linear equations, including same unknowns, x and y. All right? And let me use just some random numbers. Let's say that 3x plus 2y should be equal to 8, for example, and let's say that 6 times, or not 6, 5 times x minus 3y, or 4y, for example, and it should be equal to, let's say that 6. All right? Now we have two different equations, two different unknowns, and we can easily solve this system, right? From the knowledge from high school or from some other previous lectures, we can solve this system easily. And how can we solve? How can we solve? We can use these two equations. Let's give some names, 1 and 2, and we can just write these equations and take a sum of these two equations, right? 5x minus 4y equals 6. And the only thing I should do is multiply this first equation, for example, with 2, right? So I'm going to have a new set of equations then. And my first equation becomes 6x plus 4y equals to 16, and my second equation remains the same, 5x minus 4y equals to 6. So if I take a sum of these two equations, then I get 11 times x, and we don't have any coefficients for y, and it will be equal to 22. So we can find the value of x from this set, and x will be equal to 2. And then I can use this value, any of these equations, to find the value of y. For example, I can use this value in the second equation to get the value of y, and it will be 5 times 2, so it makes 10. Sorry. It makes 10 minus 4 times y will be equal to 6, and it makes 10 minus 6 will be equal to 4 times y, so y will be equal to 1. It's a very easy process to find the value of two unknowns by using two equations. But what did I do? I just generate a third equation by using these two equations, right? So at the beginning, I just have this equation 1 and this equation 2, and I generate this equation by doing something. I generate this equation, and let me name this equation as 3. All right? And I just make some operations, do some operations to get another equations by using these two equations. All right. And also, I can make this in another way to get a different third equation, and maybe I wouldn't multiply this first equation with 2, and I can just multiply this second equation with, for example, minus 1 over 2, right? Is this the same? I think it's the same. And I can find another third equation, and it will be the same one, 11 times x equal to 22, all right? And also, I can multiply this first equation with, for example, 5, and I can multiply the second equation with minus 3, all right? And let me do this operation, for example. So I will get a complete different equation, 15 times x plus 10 times y will be equal to 40. And also from the second equation, minus 15 times x plus 12 times y will be equal to minus 18, all right? And if I take a sum of these two equations, it makes 22y will be equal to 22, all right? And also, it makes another third equation, or these two equations also different, all right? So I can apply some operations to my system of linear equations. I'm allowed to make some operations to get an appropriate set, a suitable set from my equations to get a new set. All right, this is the drill. If I want to solve a system of linear equations, I'm allowed to do some operations to get some new equations, and then I'm going to take a sum of these equations to solve the system for, as a first step, for one variable. Then I'm going to substitute the value in some equations with this unknown, and I'm going to solve the system for another variable, another unknown. All right, then I'm going to start from scratch to make it clear. Let me delete this part and also this part. And I'm going to write this system in matrix form. How can I do this? For example, let's write a matrix including the coefficients of this system, of these equations, and I'm going to use coefficients from the first equation in the first row and the second equation in the second row, 5 and minus 4. And I should multiply these coefficients with the unknowns, I think, like x and y. And then the right-hand side of this matrix equation should be equal to a vector including 8 and 6. All right? And I can multiply this matrix with this vector to get this vector. How can I do this? With the first step, I'm going to multiply these 3 with this x plus these 2 with this y. So I'm going to have the first equation, 3 times x plus 2 times y should be equal to 8. And with the second row, 5 times x plus minus 4 times y should be equal to 6. So I can use this matrix equation instead of this system of linear equations. It's all right. So, and for solving this system, I want to get a new third equation like this. All right. And then I use the second equation with the value which I find from this third equation. So the new set here, this third equation and this second equation. If I write a matrix equation by using this new set, then it becomes 11 and a 0 for the coefficient of y, and from the number 2, 5 and minus 4. This is going to be my matrix, and the vector should be the same, including x and y. And the right hand side, this time from the first equation, it's going to be 22, and the second row should be equal to 6. All right. And from the other method, if we want to make the same thing for the coefficient of x, and I'm going to have another matrix equation. I don't remember the numbers, but it should be equal to 8 or some other numbers here. And I will have some numbers here, some numbers here, some numbers here, and a 0 here. All right? And if you want to see the exact numbers, I can calculate this, but let's calculate. We have the time. If you want to pass this section, it's okay. So I'm going to calculate the numbers for this second set. So I want to make 0 the coefficient of x, so it makes minus 15x. I'm going to use minus 10, so minus 5, sorry, minus 10 times y, and minus 40, and 15x minus 12y should be equal to 18. So our equation is 22. Y should be equal to 22. All right. Our other third equation is this. So I'm going to write the exact numbers here, and I'm going to use this first equation and this third equation. So I'm going to use 3, 2, x, 8, and a 0, and 22, and 22. All right. So the starting point here, this matrix equation, starting point, and for the solution after the operation, I just want to get a new system like this or like this. All right. So in this matrix, I just want to have some numbers and some zeros. All right. And let me make this clear for you. This is a 2 by 2 matrix, and we have these diagonal elements here. All right? Diagonal elements. And for this matrix, we have these diagonal elements. And we should have zeros. We should have zeros with the upper part, in the upper part of our diagonal elements, or in the lower part of our diagonal elements. All right? If we have some numbers below the diagonal elements, so this one is called lower triangular matrix. If we have some numbers in the upper part of the diagonal elements, so this matrix is called upper triangular matrix. I hope you understand. We are going to have some numbers and some zeros in our coefficient matrix. And if we have some numbers below the diagonal elements, so it's called lower triangular matrix. If we have some numbers above the diagonal elements, so it's called upper triangular matrix. All right. So we just have some coefficients and we are allowed to make some operations with this system to get a lower triangular matrix or upper triangular matrix. All right. This method is called Gaussian elimination. Gaussian elimination method. So I'm going to clear the right part. I'm going to clear the right part and continue with the Gaussian elimination. So now we start with the matrix equation. All right. We start with the matrix equation and we want to get a lower or an upper triangular matrix. We want to get a triangular matrix to solve this system. All right, and it's called Gaussian elimination method. All right, so we are just allowed to make some operations, and what are they? What are they? One. You can multiply a row with a constant. You can multiply a row with a constant. Constant means it's just a number and doesn't include an unknown x or y or some other unknown. And two, you can change one row with another, right? And you can take a sum of two rows. All right, this is our three allowed rules to get a triangular matrix from a matrix, all right, from a coefficient matrix. And as a first step, please be careful. These operations should be applied both to these matrices and also these vectors. So I'm going to use an augmented matrix first. Augmented means a matrix which is combined from two matrices with a vector. All right. So this is the system we are going to use. So I'm going to write down the augmented matrix first. So these augmented matrix includes these coefficient matrix and also these vector 8 and 6. All right, this is our augmented matrix. And I'm going to apply these three rules to this augmented matrix to get a triangular matrix. How can I do this? For example, in the first step, I want to make these 5 0. All right, and I have these three rules. So I think I'm going to multiply this first row with a constant, and then I'm going to take a sum of these new values for the first row with the second row to get the new values of the second row. What does it mean? So let's name these rows, and I'm going to use A's, A1 and lowercase a1, lowercase a2. I'm going to use the new values of a2. I'm going to use a prime for these new values. A prime 2 should be equal to a2 minus some coefficient, and let's name this coefficient, name this constant with c, and the old values of first row, a1. All right, and I'm going to make this 5 0, so it should be equal to 0, right? And the old value from the second row, it's 5 minus some constant, and the value coming from the first row is 3. All right, and I'm curious about the value of the constant. So I think I should have a minus 5 here, so I'm going to use 5 over 3, right? So we can have 0, 5 minus 5. So we can get this 0. All right, and I must do the same thing for the second column, also for this part. So I'm going to calculate the new value of this minus 4, and the previous value is minus 4 minus, and I'm going to use the same constant, minus 5 over 3, and this value is 2, and it should be equal to minus 4 minus 10 over 3, so it makes minus 12 minus 10 over 3, and it makes minus 22 over 3. All right, and let's calculate the new value for this 6. So it makes 6 minus 5 over 3, and the old value is 8. So it makes 6 minus 40 over 3, and it seems I chose wonderful values for the coefficients. And also I'm going to change the location of my camera. Sorry, I'm good here. or let's use this part. All right. And it makes 18 minus 40 over 3. So it makes minus 22 over 3. It will be the same thing. Yeah, it seems to be. So after the first operation, we are going to have 3, 2, 8, 0, minus 22 over 3, minus 22 over 3. All right? So now I have this augmented matrix. I have this augmented matrix. So I can write the equations from this augmented matrix. I can get the new set, and they are 3x plus 2y should be equal to 8, and 0x minus 22 over 3y equals to minus 22 over 3, and we can find y from here, right, as 1, and then I'm going to use this value here to get the value of x, 3x plus 2 equals to 8, so x should be equal to 2. And this part, this part is called back substitution. Back substitution. All right. So we are going to apply these 3 rules to a set of linear equations to get a triangular matrix. And in this example, I get an upper triangular matrix by using this set. And then I'm going to apply back substitution to find the values of y and x. All right, this is our method. So if we have some numbers of unknowns and the same numbers of equations, we can easily find the values of these unknowns. Oops, sorry. This is our method. This is Gaussian elimination method, and I think we need another example to make it clear for you. And also, it has an extension, Gauss-Jordan elimination, and I also show you this part. And I'm going to clear now the page. I'm going to clear the page and start with another example.